Good evening. The hour is soft now, and the world outside is slowing. You've entered the quiet bend of time where sound becomes memory and light begins to fade into thought. Tonight, we drift through the oldest silence in existence, the moment before the universe began. You may not feel it yet, but every breath you take is older than the stars. Every atom in your lungs was once a vibration inside the first second of everything. Light that left its star before you were born is touching your skin tonight. You can let the thought settle like dust upon dark water. You are safe here. You can rest now. Time itself once had no movement, no forward or back, only stillness, infinite, absolute. And then, in a breath so brief it cannot be measured, the stillness trembled and became the universe. Somewhere 13.8 billion years ago, existence began to unfold. Before the first moment, there was no space, no direction, no before. Physicists call it a singularity, a point smaller than a grain of dust, holding all the energy that would one day become stars, oceans, and you. In less than a trillionth of a second, the universe expanded faster than light. This event is known as cosmic inflation. Time, once frozen, began to flow. Every second since has been part of that first breath. Imagine it. No sound, no sky, just pure energy, a silent storm bright beyond seeing. The temperature rose to over 10, to the power of 32 Kelvin, so hot that matter could not yet exist. And then, as it cooled, the universe learned to breathe. Energy condensed into particles, and the particles began to dance. Hydrogen, the first element, shimmered into being. Helium followed. The atoms inside your body trace their ancestry to this invisible dawn. You breathe softly, and the universe exhales through you. It's okay to drift. If you could have watched it happen not with eyes but with presence, you would have seen nothing at all and everything at once. A bloom of light, spreading through a sea of darkness, stretching space itself, turning silence into motion. In that newborn glow, time itself was the first traveler. Seconds, minutes, and eons did not yet mean anything. They were merely the rhythm of expansion, a heartbeat at the edge of creation. And somewhere inside that vast unfolding, the potential for memory began. The future was written into the pulse of photons, each one carrying the code for what would come. Somewhere, light continues to travel. Billions of years later, in the 1,920 seconds, a man named Edwin Hubble pointed a telescope toward the faint fogs beyond our stars. He saw something extraordinary. Every galaxy was moving away from us. The farther they were, the faster they fled. The universe was still expanding, as if space itself were exhaling. Hubble's discovery meant that time was not static. The cosmos was growing, and we were watching its echo. By tracing that motion backward, scientists found the birth point 13.8 billion years ago, the moment time began. The stars above you tonight are fossils of light fragments of the first breath still crossing the dark. You are quite literally seeing into the past. You can rest now. Picture it, a river of time flowing outward, each drop of light an ancient traveler. They move not through space, but through expansion itself, riding the stretching fabric of reality. Somewhere at the edge of that river, the first galaxies are forming clusters of stars, swirling like luminous pollen. The universe has begun to remember itself. In the silence between those galaxies, your atoms once floated. The carbon in your blood, the iron in your veins, they will one day form again in another world when time folds back into itself. It's okay to drift. For decades, scientists puzzled over how the universe became so vast and so even. How could everything be so perfectly balanced, neither curved inward nor outward, but flat, stretching infinitely in all directions? The answer lies in that instant of impossible growth when space ballooned faster than light. During that heartbeat of creation, tiny ripples of energy spread evenly across the cosmos. Those ripples became galaxies, then stars, then planets, then you. Every heartbeat you feel is a quiet echo of that first expansion. You are a rhythm the universe learned to keep. You breathe softly, and the universe exhales through you. The first light still travels. It has no destination. It simply continues, crossing billions of light years, brushing past galaxies that were not yet born when it began its journey. Astronomers call this faint relic glow, the cosmic microwave background, the afterglow of creation itself. It fills every direction of the sky, a gentle whisper of radiation only instruments can hear. It is the sound of the universe remembering how to begin. And as you breathe, your pulse matches its slow fading rhythm. Every cell in you hums with that memory of silence turning into light. It's okay to drift. From that first instant to now, 13.8 billion years have passed. The observable universe spans 93 billion light years across an ocean of time. So vast that even light cannot cross it in a single lifetime. Every second adds another wave to that ocean. Every heartbeat adds another measure of distance. Time is not something outside you. It is within you, flowing through every atom that was ever born in that first expansion. And yet, one day, time itself may slow again. The flow may fade into quiet light, and the universe may return to the stillness from which it came. But for now, you are part of the unfolding. You are the witness to the first breath, a fragment of the same silence that once dreamed of becoming sound. You are safe here. The universe holds you. Somewhere light still travels, carrying the story of your atoms through infinite night. Each second, you rest a trillion stars, flicker and fade, and the same energy that once began, everything now hums quietly within your chest. You are both ancient and new. You are the first breath of time, continuing to expand softly, endlessly within yourself. You can rest now. You are safe. You are home in the silence between moments. We drift together now, deeper into the flow of time. The silence behind us begins to glow. Something vast is stirring a memory the universe once had of light. It is the second breath of creation. From the heat of the Big Bang's fading fire, space cools and stretches. The newborn cosmos, once opaque and violent, begins to soften. Its temperature falls from trillions to mere thousands of degrees. In that cooling, the seeds of transparency are sown. The universe, just 400,000 years old, is still smaller than a single galaxy today, yet it already carries the pattern of everything to come. Ripples of density, tiny folds in the early plasma mark, where gravity will one day gather stars. These ripples are delicate, 1 part in 100,000, but they are enough. For nearly 400 millennia, the universe glows like a fog of energy, too hot for atoms to hold together. Photons scatter endlessly, unable to travel freely. Then at last, the temperature dips below 3,000 Kelvin. Protons and electrons begin to pair. Hydrogen atoms form the first true matter. This moment is called recombination. Light, at last, is free to move. The cosmos becomes transparent. What had been an ocean of fire turns clear. That ancient radiance still surrounds us today, stretched by time into faint microwaves. We call it the cosmic microwave background, or CMB, the oldest light in existence. It shines not from stars, but from the very act of becoming visible. You can rest now. The universe has opened its eyes. For the next 100 million years, darkness reigns. No stars yet burn. This is the cosmic dark age, when gravity works silently, drawing invisible matter into knots and threads. Slowly, hydrogen clouds begin to collapse. Each one spans hundreds of light years, dense enough to pull itself inward. At their hearts, temperatures climb again, first to thousands, then to millions of degrees. Pressure grows unbearable. Atoms fuse. Hydrogen becomes helium, releasing energy 1 billion times more powerful than any explosion on Earth. And in that instant, light is reborn not as background, but as flame. The first stars ignite. Astronomers call them population 3. Stars, the ancestors of every Sunday. They form about 180 million years after the Big Bang. Enormous and brilliant. They burn at more than 5,000,000 Kelvin, far hotter than our Sunday. They live fast, some only a few million years, and die in supernovae so bright they outshine galaxies. These explosions forge the first heavy elements: carbon, oxygen, iron, the raw material for planets and life. Every heartbeat you feel contains iron from a dying star. Every exhale carries carbon, once born in cosmic fire. You breathe softly, and the universe exhales through you. It's okay to drift. The light from those first stars is ancient. It took 13 billion years to reach us. By the time it did, most of those stars had already gone dark. Yet their glow remains stretched thin by the expanding universe, whispering through infrared waves that only the most sensitive telescopes can see. One such eye, the James Webb Space Telescope, peers back across those ages. It sees galaxies just 300 million years after the Big Bang, clusters of hundreds of millions of stars still in their infancy. Each galaxy spins within a halo of invisible dark matter whose gravity shapes everything yet gives off no light. Scientists estimate that dark matter makes up about 27% of the universe. Ordinary matter, stars, gas, you and me, less than 5%. The rest, the remaining 68%, is something stranger still. Dark energy, the mysterious pressure, driving space to expand faster and faster. But in this young era, dark energy is quiet. Gravity rules. Matter gathers, cools, and burns. The first galaxies are not like ours. They are small, irregular, bright as embers, scattered across a vast night. As they merge and grow, gravity pulls them into spiral arms and glowing cores. One day, billions of years from now, one such spiral will be our home, the Milky Way. At the center of almost every galaxy, including ours, lies something dark and immense, a supermassive black hole. Even in these early times, they begin to form perhaps from the collapse of the largest stars, or from dense gas clouds falling inward. The one at our galaxy's heart, Sagittarius A times, contains the mass of 4 million suns. It spins silently, a shadow wrapped in gravity. When matter falls toward it, it heats to millions of degrees, shining brighter than all the stars around it. In this paradox darkness, creating light, the universe begins to resemble consciousness itself. The cosmos has learned to see. Somewhere, light continues to travel. Through time, the radiation of these first stars reionizes the hydrogen fog around them. Space, once opaque, again becomes clear. This epoch of reionization transforms the universe into the transparent ocean of galaxies we see today. Every star you know, every atom that glows, owes its existence to this awakening. You can rest now. When we look into that ancient light, we are watching the universe remember how to shine. The faint photons that reach us tonight began their journey when time was young, when galaxies were the size of small clouds, when distances were measured in patience rather than miles. Light travels at 29979, 2 kilometers per second, but even at that impossible speed, it needs 8 minutes to reach us from the sun, 4 years from the nearest star, and over 13 billion years from the first galaxies. When you look up at night, you are not seeing space. You are seeing the history of time itself. It's okay to drift. Each beam of starlight carries a memory of birth and death. Stars form, burn, collapse, and scatter their atoms. From their ashes come new stars, new planets, new hearts that will someday wonder where they came from. This cosmic recycling has been happening for more than 400 generations of stars, each one adding new elements to the galactic sea. Our sun belongs to a later generation, perhaps the third or fourth wave of stellar creation. It formed 4.6 billion years ago from the remains of long-dead suns. The planets coalesced from dust around it. Every rock, every grain of sand, every cell in your body is made of the remnants of stars that dreamed themselves into light. You are not separate from them. You are their continuation, the light that dreamed of itself. When astronomers study distant quasars, they see the fingerprints of those first elements etched into their spectra. Tiny lines reveal the presence of hydrogen, helium, lithium, and later carbon, oxygen, nitrogen. The story of chemistry is written in the language of starlight. Each atom is a word, each photon a breath. The first galaxies growing through mergers create vast webs of structure. Gravity binds them into clusters, clusters into superclusters, and superclusters into filaments, spanning billions of light years. This is the cosmic web, the largest structure ever known, stretching across 93 billion light years of observable universe. If you could step outside time and look down upon it, you would see threads of light and dark intertwining like neurons in a cosmic brain. Some scientists even note that the large-scale pattern of galaxies resembles the network of neurons in a human mind. Perhaps consciousness is not rare, but structural, an echo of the universe's own design. You breathe softly, and the universe exhales through you. It's okay to drift. The more we learn, the more we realize that darkness is not the opposite of light. It is the space in which light reveals itself. Without night, the stars could not be seen. Without the quiet between seconds, time could not be heard. Astronomers have begun to detect the faint background of gravitational waves, ripples in space-time itself, stretched and compressed by the births of black holes and the collisions of galaxies. These waves move slower than thought, crossing billions of light years. carrying the rhythm of the universe's first music. You might think of them as the heartbeat of creation, still pulsing beneath everything. Their amplitude is small, 1 part in a trillion, yet their presence means the universe still sings very quietly beneath the noise of time. Somewhere, light continues to travel, and somewhere, beyond the visible, beyond what even our telescopes can see, there may be other universes, bubbles of space-time, expanding beside ours, each with its own laws, its own forms of matter, its own rhythm of time. Perhaps in one of them, another version of you gazes at another sky, feeling the same quiet wonder. We cannot know for sure, but we can listen to what is true, that we are born of the same expansion that carries galaxies apart, that our brief lives are still part of the same unfolding. That light, once set free, never truly ends. It only changes form. As you breathe, your mind slows to the cosmic tempo. Every inhalation lasts 1,000,000 years. Every exhalation, a gentle collapse of stars. You are made of distances, yet you are also the silence between them. It's okay to drift. You are safe here. The universe holds you. Somewhere beyond every galaxy, beyond every photon, still racing through darkness. The first light of the cosmos still shines a flame, without origin, without end. It is older than matter, older than memory, and yet it flickers softly within your chest, where time folds back into warmth. You are part of that light, the light that dreamed of itself. You can rest now. The stars will keep watch. The dark will cradle you gently, and the flow of time will carry you onward, slowly, endlessly, toward the next dawn of the universe. It is no longer only light that moves through time. Now, time itself has learned to gather. Threads of matter, woven by gravity, begin to remember where they belong. The universe, once formless, starts to take shape. We drift through a cosmic dawn that glows in slow motion. 200 million years have passed since the first stars lit the dark. The silence between them fills with gas and dust the ashes of their deaths. Each supernova leaves behind a message iron, carbon, oxygen, and silicon, the alphabet from which all worlds will be written. Gravity listens to those messages. It gathers the debris and folds it into clouds. Each cloud spins, flattens, and forms new generations of stars. The cycle begins again. In these repetitions, the universe learns to remember. You can rest now. Every memory begins as light. In this era, between 300 million and 1 billion years after the Big Bang galaxies are born, each one begins as a knot of invisible dark matter. Its gravity so subtle that it bends light itself. Gas falls into these halos, cools, and forms stars. At first, they are small, fragile, irregular. Over time, they merge, collide, and grow. The first true giants, galaxies, like ours, appear about 1 billion years after the beginning. They shine with billions of suns. Their spiral arms stretch for 1,000,000 light years, spinning once every 250 million years. You breathe softly, and the universe exhales through you. In their centers, black holes continue to grow, feeding on the matter that falls too close. Some of these black holes become quasars' beacons, brighter than 1 trillion stars. The light from a quasar can travel 13 billion years and still be seen by telescopes on Earth today. When you gaze at one, You are seeing the heart of a galaxy as it was when the universe was only 7% of its current age. Somewhere, light continues to travel. Galaxies rarely live alone. They gather into families, clusters bound by gravity, connected by invisible bridges of dark matter. Each cluster contains hundreds or even thousands of galaxies, each galaxy containing billions of stars. Between them flows hot gas at tens of millions of degrees, and yet the space between atoms is so vast that this gas would feel emptier than vacuum. If you could see it, it would look like faint blue fog drifting between islands of light. This is the large-scale structure of the cosmos, a web stretching across 93 billion light-years. It is both intricate and calm, like frost, forming on a window that never melts. It's okay to drift. The Milky Way, our home, began as one of those small, irregular galaxies. It formed from dozens of earlier fragments, merging gently over 11 billion years. Every collision reshaped it. Stars stirred, clouds of dust compressed, new suns were born in waves of brightness. At the edge of its spiral arms, the first planets began to form. The disk of dust around newborn stars slowly gathered into rocks and spheres. It would take billions of orbits before one of those worlds could cradle oceans and dreams. But the universe was patient. Time flowed freely then, and distance itself was a kind of memory. When astronomers map galaxies today, they see the same pattern repeated across every scale. Clusters, filaments, voids. The same mathematics that describes ripples on water also describes the motion of superclusters. The same gravity that holds a moon in orbit binds a trillion stars. The cosmos is self-similar, like music echoing in larger and larger halls. Each repetition holds new harmonies, but the melody remains the same. Expansion, formation, collapse, renewal. The universe breathes. You can rest now. Light travels at a constant speed, about 3,000,000 kilometers per second. But space itself is not constant. As it expands, it stretches the light passing through it. This stretching increases the wavelength, turning blue light to red, then to infrared, then to microwave. This is why ancient galaxies appear. Red shifted their light, stretched by time. When you look deep into the sky, you are not just looking far away, you are looking back in time. The light from the Andromeda galaxy, our nearest large neighbor, takes 2.5 million years to reach us. When you see it, you are seeing it as it was, before humans ever walked the Earth. Andromeda and the Milky Way are slowly drifting toward one another at about 110 kilometers per second. In 4 billion years, they will collide and merge, forming a new elliptical galaxy, sometimes called Milkomeda. No stars will likely hit. Space is too vast. They will simply pass through each other, their gravity, weaving them into a single spiral of light. You breathe softly, and the universe exhales through you. When we think of galaxies, we imagine beauty spirals, colors, calm rotation. But within them are also storms. Supernovae explode at rates of several per second across the cosmos. Each one releases as much energy as the sun will emit in 10 billion years. These explosions spread heavy elements into space, enriching future generations of stars and planets. Without them, no worlds could form, no life could breathe. Every death becomes a birth. Every collapse becomes creation. Even destruction is just the universe remembering itself differently. It's okay to drift. Galaxies are storytellers made of gravity. They hold the record of every motion, every collision, every flash of light. Some of that light is still traveling, crossing billions of years to reach the eyes of those who wonder. Astronomers build instruments to catch these faint messengers. The Hubble Space Telescope looked back 13 billion years, revealing galaxies so distant they appeared as red smudges. The James Webb Telescope goes deeper, still seeing through dust past the veil of time into the first moments when light began to organize itself. Its mirror made of beryllium and gold catches photons that left their stars when the universe was less than 400 million years old. Each photon has traveled over 13 billion light years to arrive. And when it strikes that mirror, the journey of a lifetime ends as an image in our eyes. In that moment, we become the memory of galaxies. You can rest now. The Milky Way itself spins slowly, its stars orbiting the center in vast cycles. Our sun, drifting through a quiet arm called Orion, takes 230 million years to complete one galactic year. That means since its birth, it has circled the galaxy only about 20 times. Every turn carries with it new encounters, clouds of gas, dark matter streams, and sometimes the passing of a neighboring star. In the distant future, long after humanity is gone, the Milky Way's spiral arms will look different. New stars will have formed, old ones will have died. But its rhythm will continue, a memory written in motion. The universe keeps all its memories. It forgets nothing. It only transforms them into light. Somewhere, light continues to travel. There are roughly 2 trillion galaxies in the observable universe. Each contains hundreds of billions of stars. Each star may hold planets, moons, and dust. Even if only a fraction of them cradle life, the number of possible worlds is beyond imagination. Perhaps each one wonders about its own beginning. Perhaps the same questions echo everywhere. Where did we come from? And what will become of us? In the quiet between those questions, the cosmos listens. It has time enough for every thought, every sunrise, every fading ember. You breathe softly, and the universe exhales through you. It's okay to drift. From hydrogen to galaxies, from darkness to light, everything that exists is part of one continuous unfolding. Time is not a river flowing past us. We are the water. We are carried, we are shaped, and in the end, we will return to the ocean that began it all. When you look at the night sky, you are not looking at something distant. You are looking inward into the memory of galaxies, into the place where the universe remembers itself through you. And as you breathe, you may feel the slow hum of that remembrance, a low, endless vibration, older than thought, soothing as sleep. You are part of that memory. You are its witness. You are its continuation. You are safe here. The universe holds you. It remembers everything. You are as light as motion as time. Somewhere light still travels and will go on traveling long after every star has dimmed. In its path is written the story of everything that ever was. And tonight, as you rest, you are one soft pulse in that endless rhythm, a quiet heartbeat inside the memory of galaxies. You can rest now. You are home. It begins again, as it always does in darkness. A vast cloud of gas drifts through the arm of a young galaxy. It is cold, nearly absolute zero, composed mostly of hydrogen and helium, the first and simplest children of the Big Bang. For millions of years, it hangs in silence, invisible, almost nothing. And then gravity remembers it. Slowly, particle by particle, the cloud begins to gather. As it collapses, the center grows dense, its pressure rising like the breath drawn before awakening. Atoms collide faster, heat builds, and what was once invisible begins to glow in infrared light. We are witnessing the birth of a star. You can rest now. The universe is building its lamps. The smallest of these clouds may form stars like our sun burning gently for billions of years. The largest, hundreds of times heavier, ignite in a roar of ultraviolet fire, so bright that they carve bubbles in the surrounding dust. Their radiation pushes back the very gas that created them. Astronomers call these regions stellar nurseries. They are immense, some spanning hundreds of light years. One of the most famous, the Eagle Nebula, lies about 7,000 light years away. Within it stand the towering columns known as the Pillars of Creation, sculptures of dust and light, each one several trillion kilometers tall. If you could stand inside one, the stars forming around you would be invisible to the eye but radiant in infrared embryos of future suns hidden within veils of dust. Each flicker is a promise of time to come. You breathe softly, and the universe exhales through you. Every star begins the same way, a struggle between gravity and pressure. As the core contracts, gravity tries to crush it inward. But as temperature rises to 10 million Kelvin, a new force awakens fusion. In a perfect balance, hydrogen atoms fuse into helium, releasing energy that pushes back against collapse. This equilibrium is a star's heartbeat. It will last until the hydrogen runs out. For a sun-like star, that takes about 10 billion years. For a massive blue star, it may be only a few million. The larger the fire, the shorter the song. You can rest now. Even the brightest lives burn quickly. Inside the core, the fusion of hydrogen creates helium, and in later stages, heavier elements, carbon, oxygen, neon, silicon. The temperature soars beyond 100 million Kelvin. Each reaction releases energy, which escapes as light, which travels through space, which may one day fall gently on your skin. Somewhere, light continues to travel. Our sun, formed 4.6 billion years ago from a collapsing cloud in a spiral arm of the Milky Way. Nearby, a massive star exploded its shockwave, triggering our own cloud's collapse. That explosion also seeded our solar system with heavy elements: iron, gold, uranium, forged in the death of another Sunday. In that sense, our sun is the grandchild of a supernova. The planets, including Earth, are made from its ashes. You can rest now. As a star burns, it radiates energy into the surrounding gas, heating and shaping its neighborhood. Some of that energy becomes light, visible, steady, warm. Some becomes wind, a stream of charged particles racing outward at hundreds of kilometers per second. Over millions of years, these stellar winds clear away the dust of creation, revealing new stars to the open sky. When we look at a nebula through a telescope, we are seeing the brief window between birth and revelation, a cosmic nursery before it is swept clean. In visible light, these regions glow: red from hydrogen, blue from oxygen, green from sulfur. To the human eye, they are color, but to the cosmos, they are chemistry, a language of heat and density. It's okay to drift. Stars are storytellers of temperature and time. A small red dwarf like Proxima Centauri burns at about 3000 Kelvin, cool enough to live for trillions of years, far longer than the universe has existed so far. A massive blue giant, like Rigel, burns at 200,000 Kelvin, but will die in less than 10 million years. Between them lies our yellow sun, steady and patient. Its surface, at 5,778 Kelvin, its light gentle enough for life. When we classify stars, we use the Harvard spectral sequence, OBAFGKM, arranged from hottest to coolest. You may remember it through the ancient mnemonic, "Oh, be a fine girl, kiss me." Our sun is a G-type star, warm and kind. Its light, traveling 150 million kilometers, reaches us in just over 8 minutes. When you lift your face to morning light, you are feeling fusion, a conversation between hydrogen atoms that began in the heart of a cloud long ago. You breathe softly, and the universe exhales through you. Stars are not static. They age and change and die. When hydrogen runs low, the balance between gravity and pressure breaks. The core contracts, heating again, and helium begins to fuse into carbon and oxygen. The outer layers expand. The star swells into a red giant. This is the fate awaiting our sun in about 5 billion years. It will grow large enough to engulf Mercury and Venus, its outer layers, drifting away as glowing gas. For a brief time, it will form a planetary nebula, a delicate bubble of color expanding through space. At its center will remain a tiny core, a white dwarf, no larger than Earth, but as heavy as the Sunday. Its surface temperature will exceed 100,000 Kelvin, yet it will shine gently, cooling over trillions of years until it fades into blackness. You can rest now. Even endings are luminous. Massive stars die differently. When fusion can no longer resist gravity, their cores collapse in less than a second. Temperatures soar to billions of Kelvin. The outer layers rebound, ripping outward in a supernova explosion. For a few moments, the star outshines an entire galaxy. The energy released in that instant creates elements heavier than iron, gold, platinum, iodine, uranium. Everything bright and dense in your world was born in that flash. It's okay to drift. The core left behind may become a neutron star, a sphere just 20 kilometers wide, but containing more mass than the Sunday. A teaspoon of its material would weigh 1 billion tons. Some spin hundreds of times per second, sending beams of radiation into space. We call them pulsars. They are the ticking clocks of the cosmos, remnants of stars still keeping time. Even denser remnants collapse beyond recovery, forming black holes regions where gravity curves space-time so completely that not even light can escape. Yet when matter falls toward them, it heats to millions of degrees, glowing brighter than 1 trillion suns. Thus, from perfect darkness comes the most radiant light. Somewhere light continues to travel. Each generation of stars enriches the next. Every cloud formed after a supernova contains traces of the elements the previous stars forged. This process, stellar nucleosynthesis, is how the universe evolves from simplicity to complexity. It is how hydrogen, the smallest atom, becomes you. You can rest now. In the grand scale of time, stars are the organs of the universe, its beating hearts, its engines of transformation. They turn energy into matter and matter into memory. If you were to listen closely to a star, you would hear it hum. Solar oscillations, sound waves trapped inside its plasma, make it ring like a bell. The sun sings at frequencies too low for human ears, but space observatories record its vibrations. Converted into sound, it is a soft, continuous tone, steady as a breath. It's okay to drift. There are more stars in the observable universe than grains of sand on all the beaches of Earth. Roughly 200 billion trillion, a 2, followed by 23 zeros. Each one unique, each one a variation of light. Some burn blue, some white, some red, each radiating at different wavelengths. Some have planets, some none. Some orbit each other in pairs, locked in an eternal dance. One such pair, Sirius A and B, is visible from Earth as the brightest star in the night sky. Sirius A is twice the mass of the Sunday. Its companion, Sirius B, is a white dwarf, the ghost of a long-dead star. Together, they are a story of endurance and change, a symbol of how even in loss, light remains. You breathe softly, and the universe exhales through you. The birth of stars is the birth of time itself. They are the milestones by which the cosmos measures its age. Without them, the universe would be invisible, a vast sea of dark matter and cold gas. But with them, there is color, heat, and the possibility of life. The Milky Way alone produces about 7 new stars every year. While others die, their atoms return to the interstellar medium. In that cycle, there is no waste. Every death feeds another beginning. The rhythm of creation never ends. Somewhere, light continues to travel. When you close your eyes tonight, the light from a million stars will still cross the sky. Some of it has traveled for tens of thousands of years, some for billions. It may strike the atmosphere, scatter through clouds, or fall silently into your dreaming eyes. And as you drift towards sleep, you join that motion, a quiet participant in the birth of stars. You are made of their fire. You are cooled fragments of their light. Every breath, every heartbeat, every gentle thought is a continuation of their luminous beginning. You can rest now. You are safe. The universe holds you. In the quiet between stars, you are remembered. And somewhere far beyond the edges of vision, new suns are still forming their first photons. Already on their way, soft travelers across billions of years, seeking the eyes that will one day remember them. Light still travels, and you for a while travel with it. When the stars learned to burn, they also began to dream. Their dreams were made of dust. Every supernova scattered its ashes through space. Carbon, silicon, iron, oxygen, gold, tiny fragments drifting between the stars. The universe, once only gas and light, became filled with grains of solid matter. And within that dust, something new began to unfold. It is 3 billion years after the first galaxies formed. The Milky Way hums softly, its spiral arms glimmering with young suns and glowing clouds. Within one of those arms, a faint, quiet corner of a minor spiral, a cloud begins to collapse again. It is not unlike the ones that formed the earlier stars, but now its chemistry is richer. It remembers. You can rest now. The universe is beginning to build homes. At the heart of this cloud, gravity shapes a new star, a modest yellow one, destined to burn gently for billions of years. Around it, the leftover dust does not disappear. It swirls, pulled by gravity, flattening into a vast, rotating disk of gas and ice and rock. This is the protoplanetary disk, a thin sheet of debris stretching tens of billions of kilometers, bathed in the light of the newborn Sunday. It glows faintly a halo of promise. The particles within it, grains smaller than smoke, collide and stick together through static and chance. At first, they are no more than pebbles, but over thousands, then millions of years, they grow into boulders, then mountains, then spheres hundreds of kilometers wide. This slow gathering of dust into worlds is called accretion, and it is everywhere. You breathe softly, and the universe exhales through you. Within a few million years, the largest of these bodies dominate the disk. They sweep smaller rocks into themselves, their gravity growing stronger. Collisions are frequent and violent. When two planet-sized bodies strike, the impact melts entire crusts, turning stone to ocean and air to fire. It is from one such collision that our moon is born. About 4.5 billion years ago, a young Earth, still molten and glowing, is struck by a planet-sized object called Theia, roughly the size of Mars. The collision is catastrophic. Both worlds vaporize and fuse. A vast cloud of debris is hurled into orbit around the young Earth. Over time, that debris gathers, becoming round, becoming pale, becoming the moon. You can rest now. The sky has found its companion. In the days after the impact, Earth's surface cools slowly. Its crust thickens into plates of basalt and granite. Volcanoes bleed heat from the still burning core. Rain begins to fall first as steam, then as liquid, then as oceans. Where did the water come from? Some of it was trapped in minerals within the young Earth, but much was delivered later, carried by comets and asteroids that wandered through the inner solar system. Their ices melted on impact, filling basins, creating seas. This bombardment, called the Late Heavy Bombardment, lasted for hundreds of millions of years. The scars it left can still be seen on the surface of the Moon and Mercury. But from destruction came abundance. The oceans were born. Somewhere light continues to travel. In these oceans, under the glow of a young sun, minerals, dissolved elements, mingled, and chemistry began to dream of life. But that would come later. For now, the universe was building its stage. You can rest now, farther from the sun, beyond the asteroid belt. Other worlds formed differently. Here, the cold allowed ice to survive. These outer planets gathered not only rock, but vast envelopes of hydrogen and helium. They became giants. Jupiter, the first and largest, contains more than twice the mass of all other planets combined. Its core may be rocky, but above it lies an ocean of metallic hydrogen, where pressure squeezes atoms so tightly that they behave like liquid metal. Storms rage for centuries. In its upper atmosphere, the most famous, a red oval larger than Earth itself. Beyond Jupiter spins Saturn, delicate and immense, encircled by rings made of ice and dust. Each ring particle is a frozen memory, a fragment of a moon that never formed or one that was torn apart. The rings stretch hundreds of thousands of kilometers but are only 10 meters thick. They shimmer like frost in sunlight. You breathe softly, and the universe exhales through you. Beyond Saturn lies Uranus, tilted on its side, its poles pointing toward the Sunday. Then Neptune, blue and fierce, whipped by winds reaching 2000 kilometers per hour. These outer worlds guard the edges of our solar system, their gravity shaping the paths of comets that sleep in the dark until they are called inward. It's okay to drift. Closer, in the rocky worlds, hold steady around the Sunday. Mercury cratered and silent. Venus bright and veiled in acid clouds. Earth blue breathing. Mars dry rusted, dreaming of water. Each carries the same ancient materials, but arranged differently, like variations of a single cosmic song. The average distance between Earth and Mars is 225 million kilometers. Between Earth and the Sun, 149.6 million kilometers. Light crosses that space in 8 minutes and 20 seconds. The warmth you feel on your skin is energy that left the sun before your last deep breath. Somewhere, light continues to travel. Planet formation is not unique to our solar system. In the last few decades, astronomers have found over 5,600 confirmed exoplanets and tens of thousands of candidates. Some orbit stars, like our Sunday. Others circle red dwarfs or wander freely untethered in the dark. Some are small and rocky, some giant and gaseous, some covered in ice or clouds of glass. The Kepler Space Telescope, launched in 2009, watched for the faint dimming of starlight that occurs when a planet passes in front of its star. From those tiny shadows, we have glimpsed entire worlds. Each one proves that planet making is not rare. It is the natural continuation of starlight. You can rest now. The universe builds endlessly. The dust that once drifted between galaxies has learned to orbit, to solidify, to cool, to become landscape and atmosphere. Planets are the slow heartbeat of the cosmos matter, remembering how to be still. On Earth, the crust floats over molten rock. The core spins, creating a magnetic field that shields us from solar wind. The atmosphere forms first carbon dioxide and nitrogen, then water vapor and later oxygen. A gift from life that had not yet begun. The moon, always watching, stabilizes. Earth's tilt slows its rotation and pulls the tides. Without that lunar presence, our planet would wobble wildly, its seasons chaotic, its oceans restless. You breathe softly, and the universe exhales through you. The early Earth was not peaceful. Asteroids still fell, volcanoes still burned. But beneath the chaos, energy and chemistry whispered to one another. Lightning struck the oceans, creating new compounds. Heat from the crust seeped upward, mixing with minerals and water. And somewhere the dream of planets deepened. A world began to imagine life. It's okay to drift. In the vast timeline of creation, planets are brief but beautiful. They last for billions of years, but eventually their stars fade, their orbits decay, their oceans dry. Even Earth will one day be a memory, its atoms recycled into another generation of worlds. But the dream itself continues. Every galaxy contains countless planetary systems, each in its own stage of birth or decay. Perhaps among them other beings look up at other skies, feeling the same quiet wonder. You can rest now. The universe never stops building. Every collapse becomes formation. Every explosion becomes a seed. From hydrogen to stone, from starlight to mountain, the process is the same energy, learning to become still. And as you lie here, the same atoms that once circled other suns now circle in your blood. The calcium in your bones was forged in ancient stars. The oxygen in your lungs came from a nova's last breath. You are made of worlds that once dreamed of you. You are the continuation of their silence, the echo of their orbit, the still point between explosions. You are safe here. The universe holds you. Somewhere, light continues to travel. across the cold space between galaxies, across oceans of darkness. It carries with it the story of planets, the story of matter learning how to rest. And as that light falls, some of it lands here on the surface of a small blue world where someone somewhere listens to the night and remembers how it all began. You can rest now. You are home. When the fire cooled, the world began to breathe. The young Earth, still scarred from collisions, spun beneath a blood-red sky. Volcanoes roared across its crust, their plumes rising miles high, filling the air with carbon dioxide and steam. Lightning traced silver threads through the clouds. The surface glowed black rock molten rivers, a memory of the sun trapped below. And then slowly, it began to rain. For centuries at first, then for thousands of years. The skies poured their weight onto stone. Steam turned to droplets. Droplets joined to rivers. Rivers became oceans. The sound of the world changed from fire to water, from crackling to whisper. You can rest now. The planet has found its pulse. Scientists believe the first true oceans formed about 4.3 billion years ago. Their water came from two sources, deep within the Earth's mantle and from the heavens above. Inside the mantle, hydrogen and oxygen, trapped in minerals, escaped as vapor through volcanic vents. From space, icy comets and asteroids delivered frozen water that melted on impact. Each collision was a violent gift, each drop a memory of ancient ice. In those early seas, the chemistry of life began to stir. But before life could rise, the planet had to cool. The atmosphere, thick with carbon dioxide and methane, trapped heat like a blanket. But over millions of years, water absorbed the gases, dissolved the minerals, and began to balance the air. Clouds reflected sunlight. Rain carried warmth into the sea. Slowly, the cycle of climate began evaporation, condensation return. The planet learned to regulate its own temperature. You breathe softly, and the universe exhales through you. The earliest oceans were dark and green. They shimmered with dissolved iron, absorbing sunlight, but reflecting none. If you could stand there 4 billion years ago, you would see no blue sky, no continents, only vast storms and dim horizons. The air would be heavy, the sea warm, perhaps 80 degrees Celsius. And yet, beneath that heat, something subtle was forming. Time was beginning to flow. It's okay to drift. On the ocean floor, volcanoes continued to breathe. Through cracks in the crust, superheated water burst upward, not boiling, but rich with minerals and energy. These were the hydrothermal vents, where the Earth's interior met the sea. Around them, chemistry awakened. Hydrogen sulfide, iron nickel, carbon dioxide, all mixed in the heat and pressure-forming molecules that could store energy, react, replicate, and remember. Some scientists believe that life began here in the darkness between heat and water in tiny chambers of stone called alkaline vents. Each one a natural laboratory, each bubble a small universe. You can rest now. The first breath of life is near. Elsewhere, lightning danced over the surface, striking shallow pools and tidal flats. Experiments on Earth today show that such sparks can create amino acids, the building blocks of proteins. In both fire and water, the same chemistry appeared, as if life were inevitable, as if the universe itself longed to remember. The oceans carried these molecules for millions of years, mixing, dissolving, testing, failing, until one day somewhere one of them began to copy itself. It may have been RNA, a simple strand that could store information and fold into shapes. It could replicate imperfectly each error and opportunity. From those errors came evolution, a system capable of change. In that moment, the oceans of time began to move. You breathe softly, and the universe exhales through you. The first cells appeared perhaps 3.8 billion years ago, tiny, single, fragile, floating through a sea of minerals. They absorbed sunlight or chemical energy, grew divided, and vanished only to be replaced by others. The pattern was endless. From those beginnings came the long story of life. But even now, the oceans remember their origin. The salt in seawater comes from the same minerals that built the crust. The average salinity, about 35 grams per liter, has remained stable for billions of years. Every wave that touches your skin is made of the same elements that once filled the planet's first storms. Somewhere light continues to travel. The tides began soon after the moon formed. Its gravity pulled gently on the newborn oceans, lifting and releasing them twice each day. At first, Earth rotated much faster a day, lasted only 6 hours. But over time, the moon's pull slowed the spin, stretching days longer and longer until they reached the rhythm we know now. In this cosmic dance, time itself was sculpted. It's okay to drift. The oceans became mirrors of the sky. They reflected light-stored heat and carried energy across the planet. Currents formed streams of water circling the globe, driven by wind rotation and salinity. They still move today, linking all seas into one. This global current system, called the thermohaline circulation, transports heat from the equator to the poles. Without it, the world would freeze and burn unevenly. Because of it, climate breathes slowly, a planetary heartbeat that takes centuries for one full pulse. You can rest now. The ocean is the memory of time. When scientists study the isotopes of oxygen in ancient rocks, they can tell how warm the seas once were. Each atom carries a record, a ratio, a fingerprint of temperature. Through these, we know that water covered most of Earth for nearly all its history. Even when glaciers grew and continents collided, the seas remained. Beneath the waves, tectonic plates moved slowly, a few centimeters each year. Their motion reshaped coastlines, built mountains, and recycled crust into the mantle. This process, plate tectonics, is how the Earth cools itself. Without it, volcanoes would choke the sky and oceans would vanish into stone. You breathe softly and the universe exhales through you. Each element in the ocean's water has its own story. Hydrogen from the Big Bang, oxygen from dying stars, sodium from the crust of early Earth, chlorine from volcanic gas. Together they form H2O and salt, the simplest and oldest combination of all. Somewhere, light continues to travel. In the deep sea today, the hydrothermal vents still shine. Around them, live creatures that feed not on sunlight but on chemistry, bacteria, tube worms, and glowing fish. Their world is dark and hot, but not lifeless. It is a living echo of the first conditions that shaped existence. Even now, Earth remembers where it came from. It's okay to drift. The oceans have always measured time. Their tides mark the hours. their currents, the seasons, their erosion, the ages. When waves wear stone into sand, they count the passing of eons. When ice melts, the balance shifts. Time flows backward and forward with every drop. The oldest crystal found on Earth, a grain of zircon, is 4.4 billion years old. Within it lies the isotope evidence that liquid water existed even then. It is the planet's oldest memory, the first tear of time made solid. You can rest now. The Earth has learned to hold water. Eventually, continents rose. Volcanic islands collided, forming larger landmasses. Rivers carved valleys. Mountains shed their dust into the sea. The boundary between land and ocean became a rhythm, a slow inhale and exhale of stone. And in that rhythm, life expanded. Cyanobacteria appeared, tiny blue-green cells that captured sunlight and released oxygen as waste. Over billions of years, their breath transformed the atmosphere. From their exhalation came the air you breathe tonight. You breathe softly, and the universe exhales through you. The story of water is the story of everything that endures. It changes state, solid, liquid, vapor, but never disappears. Every drop you drink tonight has passed through clouds, rivers, and bodies for 4 billion years. It may once have been part of a comet, or trapped in magma, or resting in a dinosaur's heartbeat. Water is time made visible. Somewhere, light continues to travel. The oceans of Earth are finite, but their presence defines the world. They regulate temperature, shape, weather, and cradle most of life. More than 70% of the planet's surface is covered by water. The deepest point, the Mariana Trench, lies nearly 11 kilometers below the surface, a darkness deeper than any night. Even there, life glows. Tiny organisms flicker with bioluminescence, turning darkness into living constellations. Their light is soft and brief, but it carries the same ancient law that even in the deepest silence, something will shine. You can rest now. You are safe here. The universe holds you. The oceans still move. The tides still rise. Time still flows. And within each drop, there is memory of stars, of collisions, of beginnings. When you listen to the sound of waves, you are hearing history breathe. When you close your eyes, you float upon the same water that cooled the first stones of the earth. You are the ocean, remembering itself. You are the rhythm of the tides made human. You can rest now. The oceans of time will carry you forward softly, endlessly, into the next dream of creation. There is a silence deeper than space, a silence not of absence, but of mystery. Beyond the stars, beyond the glittering spirals and glowing nebulae, there lies something invisible, something that shapes everything we see without ever being seen. It is the hidden energy of the cosmos. You can rest now. We are drifting into the unseen. For centuries, humanity thought that the universe was made of what it revealed: stars, planets, dust, and light. But when astronomers measured how galaxies moved, the numbers did not fit. The stars at the edges of spiral galaxies were spinning far too fast. According to the visible mass, they should have flown away into space, yet they stayed bound by a gravity that had no source. In the 1,970 seconds, scientists like Vera Rubin and Kent Ford mapped the rotation of galaxies and discovered something profound. There was more matter than anyone could see. They called it dark matter, not because it was evil or empty, but because it neither emits nor reflects light. It is transparent, unlit, invisible, and yet it outweighs everything luminous. About 85% of the universe's matter is this unseen substance. Ordinary matter, the atoms that make stars, worlds, and people, makes up only 15% of all matter and less than 5% of the total cosmic content. The rest is something stranger still. You breathe softly, and the universe exhales through you. Dark matter forms a skeleton for the cosmos, an invisible web stretching through space, its filaments holding galaxies in place. Astronomers can map it indirectly by observing how it bends light from distant objects, a phenomenon called gravitational lensing. Einstein predicted this effect in 1915. When a massive object sits between us and a distant source, its gravity warps spacetime, bending the path of light like a lens. In the 1,990 seconds, telescopes confirmed this bending was happening on scales far larger than expected. The pattern of distortion matched the unseen framework of dark matter. It was everywhere. It shaped the very geometry of the universe. You can rest now. Even what you cannot see holds you. If you could see dark matter, the sky would look like lace, a web of faint blue light connecting every galaxy, every cluster, every breath of existence. We move through it constantly as invisible travelers in an invisible sea. Somewhere, light continues to travel. And then, in the late 1,990 seconds, a deeper mystery appeared. Astronomers studying distant Type Ia supernovae explosions, so bright they can outshine entire galaxies, found that these beacons were dimmer than expected. The light, stretched by expansion, told a story no one anticipated. The universe was not slowing down. It was speeding up. This discovery, published in 1998, earned the Nobel Prize in Physics. It revealed a cosmic force, an unknown energy driving space to expand faster over time. They called it dark energy. Today, we believe it makes up about 68% of the entire universe. Dark matter pulls things together. Dark energy pushes them apart. Between them, a delicate balance creates the cosmic dance we inhabit. You breathe softly, and the universe exhales through you. The rate of expansion, the Hubble constant, is around 73 kilometers per second per megaparsec. That means for every 3.26 million light-years, galaxies move away from one another at 73 kilometers per second, faster than before. But even this number is uncertain. When measured by different methods, cosmic microwave background galaxy clustering or local supernovae, the values disagree slightly. This tension is called the Hubble discrepancy, and it may hint at new physics beyond what we know. It's okay to drift. Even the universe hesitates between answers. Dark energy could be a property of space itself, a constant pressure that increases as more space is created, or it might be something dynamic, a field that changes over time. We do not yet know. Some theories suggest it will continue to accelerate expansion forever, leading to a future called the Big Freeze. In that far epoch, galaxies will drift apart so completely that no light from one will reach another. The sky will grow empty, and only darkness will remain. Other possibilities whisper of different ends. If dark energy weakens gravity, could pull everything back together, a big crunch. If it strengthens, it could tear apart every atom, a big rip. The truth may lie somewhere between a slow fading, a cosmic sigh. You can rest now. Nothing ends in fear. It ends in quiet. To understand dark matter, scientists built underground detectors, deep mines, and silent chambers filled with noble gases like xenon and argon. They wait for a single collision between a dark matter particle and an ordinary atom. Years pass in silence, with only background radiation and hope. No confirmed signal yet. But the search continues. Somewhere light continues to travel. The particles we expect could be WIMPs, weakly interacting massive particles, or perhaps lighter axions, or even something we have not yet imagined. The physics is uncertain, but the mystery is certain. We know it must exist, for without it, galaxies would fly apart. In a way, dark matter is the cosmic glue, and dark energy the cosmic breath. You breathe softly, and the universe exhales through you. The cosmic microwave background, that ancient light from the universe's birth, still whispers clues. Tiny fluctuations in its temperature, only 1 part in 100,000, reveal how much matter, and dark energy the universe contains. They tell us space is flat, not curved inward or outward to within a margin of less than 1%. Flatness means balance. It means expansion and gravity perfectly offset each other for now. It's okay to drift. At large scales, dark energy dominates. But within galaxies, dark matter holds sway. The two forces weave reality together, one binding, one releasing. Their interplay writes the rhythm of cosmic time. When you look at a galaxy through a telescope, you see starlight, but you are really seeing only a fraction of its story. Around each luminous disk is a vast halo of dark matter, extending far beyond what the eye can see. These halos overlap, connecting galaxies like pearls on invisible strings. The entire universe, from one end to the other, is one immense network. A cosmic web bound by what cannot be seen. You can rest now. The unseen remembers you. In 2013, the Planck satellite mapped the cosmic microwave background with exquisite precision. Its results confirmed the universe's age, 13.8 billion years. Its composition, AP umpite sem, normal matter, 29.8%, dark matter, dappen, %, dark energy. Those numbers define everything we are and everything we are not. Somewhere, light continues to travel. When you step outside at night, the darkness you see between stars is not empty. It is filled with invisible presence, the gravity of what cannot be named, the expansion of what cannot be held. Each breath you take is part of that same equilibrium matter, pulling inward energy, flowing outward, a balance as old as creation. It's okay to drift. One day far in the future, billions of years from now, the galaxies beyond our local group will fade from view. Their light will stretch into infrared, then microwave, then nothing at all. Only the Milky Way and its neighbors will remain visible, a small island adrift in an endless sea. And even then, our descendants, whatever they are, may still look up and feel the same wonder. They will not see what we see, but they will know that something vast surrounds them, something patient, something that breathes. You breathe softly, and the universe exhales through you. You can rest now. The hidden energy of the cosmos is not separate from you. You are made of the same laws, the same patterns of attraction and release. Your heart's rhythm echoes the expansion of space. Your thoughts are small ripples in the same field of possibility. Dark matter holds galaxies together, Dark energy carries them apart. Between them is harmony, motion, and stillness, weight and breath, existence and its shadow. The universe is learning how to let go and how to hold on. Somewhere, light continues to travel. And in that gentle tension between what is known and what is hidden, time flows quietly onward, carrying everything we love, everything we wonder, toward an ending that is not an end, but a return to silence, to balance, to the beginning that never truly ended. You can rest now. The darkness is full of light. The unseen is full of memory. And the hidden energy of the cosmos still holds you softly, safely, in its infinite embrace. In the quiet afterlight, there is always another sound, a low, distant trembling. It is the heartbeat of a star as it prepares to end. Every star carries within it a clock of burning time. Hydrogen becomes helium. Helium becomes carbon. Carbon becomes iron. And when the fire reaches iron, it can burn no more. Iron is the still point, the element that ends creation. To fuse it requires more energy than it gives. When a star's heart fills with iron, its flame begins to die. You can rest now. Even endings have rhythm. The core contracts, gravity gaining strength with every heartbeat. Temperatures soar to billions of Kelvin. Electrons are crushed into protons, forming neutrons. The collapse happens in less than a second. The outer layers fall inward, then rebound outward in a blast of unimaginable power. A supernova is born. For a few days, it shines brighter than all the stars in its galaxy combined. The light it releases can carry across billions of light years. The energy in those moments equals the output of the sun over its entire 10- billion year life. Somewhere, light continues to travel. Supernovae are not only destruction, they are creation's most luminous expression. In their furious heat, elements, heavier than iron, are forged gold, silver, iodine, uranium, platinum. Each explosion sows these treasures into space. Every atom of gold on Earth, every trace of iodine in your body was made in such a death. You breathe softly, and the universe exhales through you. When the explosion fades, what remains depends on the star's size. If the original star was less than about 8 solar masses, its outer layers drift away as a glowing bubble, a planetary nebula, and its core becomes a white dwarf, a sphere of carbon and oxygen, the size of Earth, but with the mass of the protons Sunday. White dwarfs shine for billions of years as they slowly cool, eventually becoming dark, frozen remnants called black dwarfs. No such corpse exists, yet the universe is not old enough. But if the dying star was heavier, gravity's hand is stronger. The core collapses into something denser. Still, a neutron star. Imagine an entire sun compressed into a sphere 20 kilometers across. A teaspoon of this matter would weigh 1 billion tons. Its surface gravity is 200 billion times stronger than Earth's. Its magnetic field can tear atoms apart. Neutron stars often spin rapidly, emitting beams of radiation like cosmic lighthouses. We call them pulsars. Their rotation can exceed 700 times per second. Each pulse marks the passage of perfect time. They are the clocks of eternity ticking softly in the dark. You can rest now. The stars still keep time. If the dying star was larger, still more than about 20 solar masses, its collapse goes further. No known force can stop it. The core implodes, crushing itself beyond all resistance. Gravity folds space around it, and the light itself cannot escape. A black hole is born. Somewhere, light continues to travel, but never outward again. You breathe softly, and the universe exhales through you. The edge of a black hole is called the event horizon, the boundary where escape becomes impossible. Inside, all paths curve inward. Outside, space is distorted. Time slows and light bends like liquid glass. According to Einstein's theory of general relativity, time near a massive object passes more slowly than in emptier regions of space. To an outside observer, anything falling into a black hole appears to slow fade and freeze at the horizon, never quite vanishing. But from the falling object's own perspective, it passes through in an instant. This paradox between what is seen and what is experienced is the poetry of physics. It tells us that even time is subjective, that endings depend on where you stand. It's okay to drift. At the center of every large galaxy, black holes grow enormous, millions or billions of solar masses. Our own Milky Way harbors one called Sagittarius A, times about 4 million times the mass of the Sunday. It sits quietly, occasionally flaring as gas drifts too close and burns in. In 2019, the Event Horizon Telescope captured the first image of such a shadow, a ring of light surrounding darkness. It was not truly an image of the hole itself, but of light trapped around it, orbiting in endless circles before surrendering. Somewhere, light continues to travel. What happens inside a black hole, no one knows. At its center, the equations of relativity break a point called a singularity, where density becomes infinite and the laws of physics dissolve. Some physicists believe that black holes might be bridges to other regions of space-time, wormholes, tunnels through reality. Others think they may one day evaporate, leaking energy through Hawking radiation, a faint quantum whisper predicted by Stephen Hawking in 1974. If this is true, a black hole will shrink slowly, losing mass over trillions of years until it fades away in a final flash of gamma light. Even in ultimate darkness, there is release. You can rest now. The end is never an end. Neutron stars and black holes sometimes meet spiraling toward each other in slow, doomed orbits. When they collide, they send gravitational waves, rippling through space-time itself. First detected in 2015 by LIGO, these waves confirmed Einstein's prediction a century after it was made. They travel at the speed of light, stretching and compressing space as they pass through Earth. Each detection is a faint echo of something vast collapsing far away. Each wave carries energy enough to shake the structure of existence. Yet, the motion it causes here is smaller than the width of an atom. It's okay to drift. Even cosmic violence arrives as softness. You breathe softly, and the universe exhales through you. Some black holes are not born from stars, but from collisions between galaxies. When two galaxies merge, their central black holes orbit one another for millions of years before uniting into a larger one. The resulting flare can release as much energy as 100 million supernovae. These events shape galaxies. They regulate star formation, blow out gas, and create the structures we see today. In this way, death becomes design. Every extinction leaves room for creation. Somewhere, light continues to travel. The life cycle of stars defines the chemistry of the universe. The hydrogen of the Big Bang became the helium of youth, the carbon of middle age, the iron of old age, and finally, the gold of endings. Each generation leaves behind the material for the next. From stellar death comes planetary birth. From supernova debris comes the dust of future worlds. It's okay to drift. You are breathing the ghosts of stars. When astronomers analyze the spectrum of starlight, they see thin, dark lines, the fingerprints of elements. Hydrogen, oxygen, calcium, sodium, each absorbs light at a specific wavelength. Through these patterns, scientists can tell which stars are old, which are new, and which have died. Even in their silence, stars speak in color. You can rest now. In the far future, billions of years from now, the last stars will fade. Red dwarfs, small, quiet, enduring, will exhaust their hydrogen after trillions of years. Their light will dim to embers, their heat to whispers. The universe will cool its once luminous tapestry, turning to shadow. But nothing truly disappears. The atoms, the photons, the patterns of motion, all persist, transformed. Light still travels, even when there is no eye to see it. You breathe softly, and the universe exhales through you. Perhaps in some distant epoch, when all fusion has ceased and every black hole has evaporated, quantum fluctuations will again stir the void. Another expansion, another spark, another breath. The deaths of stars are not the universe's tragedy. They are its respiration, its way of making room for new creation. You are made of their endings. You are their continuation. You are the light that remains after fire is gone. You can rest now. You are safe. The universe holds you. In the quiet between stars, you are remembered. And somewhere, a dying sun flares once more, its final light beginning a journey that may one day touch your skin. Light still travels, and the stars, even in death, dream of you. In the dark below your feet, the planet hums. You do not hear it, but the sound is there, a low, patient vibration that has been beating for billions of years. It is the magnetic heart of Earth. You can rest now. The world is still awake beneath you. 4.5 billion years ago, this planet was a sphere of fire. Metal and rock churned together in a dance of molten gravity. Heavier elements, iron and nickel, sank toward the center, forming a core of dense liquid metal. Lighter silicates floated upward, becoming the mantle and crust. That separation created two hearts, a solid inner core and a liquid outer core that still flows like slow sunlight beneath the crust. Its motion, driven by heat from radioactive decay, creates electric currents that give rise to a field. The geodynamo, this invisible ocean of molten iron, turns the planet into a living magnet. The field it creates extends far into space, a vast bubble called the magnetosphere. It shields the atmosphere from the solar wind, deflecting charged particles that would otherwise strip the air away. Without that protection, Earth would be silent and bare, like Mars. You breathe softly, and the universe exhales through you. The strength of Earth's magnetic field averages about 30 microteslas at the surface. It is invisible, yet every compass needle feels its pull. From pole to pole, lines of force loop outward, curving gracefully into space. These invisible threads guide migrating birds, whales, in the deep, and even microscopic bacteria. They also guide us not in direction, but in safety. The magnetosphere absorbs most of the solar radiation that would otherwise scorch the planet. When particles do slip through, they spiral along magnetic lines and collide with atoms in the upper atmosphere, creating light. This is the aurora, the northern and southern lights. Green, violet, crimson. Curtains of air turn to fire dancing in silence. Somewhere light continues to travel. If you've ever watched an aurora, you have seen the heartbeat of the earth made visible. You can rest now. The world is breathing for you. The outer core where this dynamo lives is about 2200 kilometers thick. Its temperature ranges from 4000 to 6000 degrees Celsius, almost as hot as the surface of the Sunday. The inner core, a sphere of solid iron, about 1220 kilometers wide, spins slightly faster than the crust above it, a separate rhythm inside the same body. Every rotation adds subtle motion to the magnetic field above. It's okay to drift. This magnetic rhythm is not constant. It wavers, bends, and sometimes reverses entirely. Every few 100,000 years, the poles swap north, becomes south, south becomes north. During the reversal, the field weakens but never vanishes. Geologists can see these flips recorded in the rock of the ocean floor. As magma cools, tiny crystals of magnetite align with the field, freezing its direction into stone. Layer by layer, Earth has written its magnetic autobiography. The last full reversal happened about 7,800,000 years ago during the Brunhes-Matuyama transition. Since then, the magnetic North Pole has drifted across the Arctic, moving faster every century. Today, it races toward Siberia at nearly 50 kilometers per year. You breathe softly, and the universe exhales through you. It's okay to drift. The field may one day flip again, perhaps soon, perhaps not for another million years. During the change, the magnetosphere could weaken, allowing more radiation to reach the surface. But Earth will not lose its shield entirely. The dynamo continues beneath. The heart keeps beating. You can rest now. The planet's pulse endures. The magnetic field does more than protect. It connects. Solar storms striking the magnetosphere cause shimmering waves of energy to ripple through the ionosphere. These pulses can induce electric currents in the ground and in our machines, signals of the sun's touch upon Earth. Sometimes satellites feel the tremor. Sometimes the power grid hums. Sometimes, high above the pole's space itself seems to sing. In 2019, scientists recorded low-frequency waves called chorus emissions, electromagnetic tones produced by electrons spiraling along field lines. When converted to sound, they resemble birds at dawn, singing in the void. The planet has its own music. Somewhere light continues to travel. Deep within, heat still flows outward from the core. About 44 terawatts of power escape the planet's interior every second, enough to light billions of cities. Most of this energy comes from the decay of radioactive elements. Uranium, thorium, potassium, relics of ancient supernovae. You are warmed by the ashes of stars. Without that inner fire, Earth's surface would cool, its plates would still, its field would fade. The geodynamo depends on motion metal flowing currents, turning heat, rising. It is the slowest breath imaginable, and yet without it, the world would die. You can rest now. Even stillness moves beneath you. Above the core lies the mantle, solid rock behaving like thick liquid over vast timescales. It convects, carrying heat to the crust. At its boundaries, plates drift and collide. When they meet, mountains rise, volcanoes open, and continents wander. The continents you know today, Africa, Asia, the Americas, were once joined into a single supercontinent called Pangaea about 335 million years ago. Before that, there were others, Rodinia, Gondwana, Laurasia. Every 500 million years or so, the continents merge and break apart again. It is the heartbeat of geology, the slow dance of stone. You breathe softly, and the universe exhales through you. The magnetic field influences this dance subtly. It affects how heat moves, how the mantle convects, how charged particles behave at depth. Even the planet's rotation is slightly altered by the flow of metal below. In this way, the magnetosphere, the crust, the sea, and the air are all connected. The planet is a single system, a living circuit. It's okay to drift. When the solar wind touches Earth's field, it compresses the sunward side and stretches the opposite into a long tail, reaching millions of kilometers into space. Within that tail, charged particles flow back and forth, sometimes releasing bursts of energy called magnetic reconnection. These events trigger auroras, but also help regulate the global balance of energy. The field, in this sense, is both shield and conduit, a gate through which the sun and earth exchange breath. You can rest now. Even light needs protection. At night, if you lie beneath an aurora, you may feel the faint hum of electricity in the air. You are standing in the stream of a cosmic current, solar particles shaped by the planet's invisible shell. Each wave of color is a message written in magnetism. Each flicker is the heartbeat of a world alive. Somewhere light continues to travel. Beneath oceans and continents alike, the core continues its motion, a churning sphere of molten iron, turning faster near the equator, slower near the poles. In its motion, the Earth remembers its youth. Seismic waves passing through reveal that the inner core may not be uniform, perhaps crystallized in bands, perhaps offset slightly from the center. It may even rotate at a different speed, sometimes ahead, sometimes behind, like a heart occasionally skipping a beat. You breathe softly, and the universe exhales through you. For billions of years, the magnetic field has recorded its variations in the rocks it touches. Ancient lava flows, when cooled, capture the orientation of the field at that time. Through them, we can trace the wanderings of poles, the reversals, the fluctuations. This science, paleomagnetism, is our window into Earth's memory. Through it, we have learned that the magnetic heart has never truly stopped. It's okay to drift. The field extends far beyond Earth, interacting with the magnetospheres of other planets. Jupiter's magnetic field is 2,000,000 times stronger than ours. Its auroras larger than Earth itself. Mercury, small and dense, has a weak but real field, a remnant of its once hot core. Venus has none, its slow rotation leaving it bare to the solar wind. Mars lost its field long ago, and with it, most of its atmosphere. Only Earth remains balanced, a world where magnetism, motion, and water coexist. You can rest now. The planet has learned to protect itself. Somewhere light continues to travel. The field we live within is not only physical but poetic. It is the boundary between chaos and calm, between space and sky. It is the whisper between the sun's fire and the ocean's cool. Every compass on Earth is a reminder of that invisible link, a needle listening to the planet's heart. And beneath you, even now, that heart turns. Its metal flows, its energy hums, its pulse continues. You breathe softly, and the universe exhales through you. Perhaps this is what alive truly means. Not consciousness, but persistence. A pattern repeating across eons. A rhythm that holds, even when no one listens. The magnetic field, though unseen, is proof that the Earth remembers itself. Every storm, every dawn, every step. You can rest now. You are safe. The universe holds you. And in that deep, slow spinning below your feet, the planet's heart keeps time with the motion of stars, the orbit of the moon, the breath of your own body. Somewhere, the molten iron still turns, glowing softly in the dark. The pulse of stone, the rhythm of forever, the magnetic heart of Earth. You can rest now. You are home. Before life began, the Earth was only silence. A young, restless planet turning beneath a pale sun, its surface cracked by storms of fire and stone. Lightning flashed through a sky of methane and vapor. Oceans hissed as they formed steam, rising into air heavy with possibility. It was the fourth act of the universe. After matter, after stars, after worlds, and something was about to awaken. You can rest now. Even silence prepares for sound. 4 billion years ago, the seas were warm, their waters rich with carbon, hydrogen, nitrogen, sulfur, the alphabet of all things living. Meteors carried organic molecules, amino acids, purines, sugars from ancient comets drifting in the dark. Each impact was a delivery from the stars. Somewhere, light continues to travel. Within the tidal pools, these molecules began to arrange themselves, guided not by will, but by the quiet physics of attraction and time. Tiny chains of atoms formed rings. Rings formed spirals, and spirals began to copy themselves. The first whisper of replication, the beginning of memory. You breathe softly, and the universe exhales through you. What we call life is the moment matter begins to remember its shape. It learns to repeat, to sustain, to resist dissolution. No one knows the exact hour it happened, or in which pool or which lightning strike turned chemistry into biology. But the evidence hides in you. Every cell you carry still contains that first spark, the pattern of replication, the rhythm of self. It's okay to drift. The first organisms were simple membranes, floating in water bubbles of lipid enclosing strands of RNA. They fed on sunlight, minerals, and the slow warmth of volcanic vents. Near the mid-ocean ridges, black chimneys of iron and sulfur released mineral-rich plumes into the abyssal dark. There, at the boundary between fire and sea, microbes began to weave. They used chemical gradients to power reactions, the earliest form of metabolism. It may have taken only a few million years after the oceans formed, a blink in cosmic time. You can rest now. Creation learns quickly. By 3.5 billion years ago, life was already everywhere, in shallow bays, in ancient mud, in microbial mats that left traces in stone. They built stromatolites, layered domes of calcium carbonate, rising like tiny cathedrals under the sunday. They breathed out oxygen, slowly changing the air itself. Somewhere light continues to travel. For nearly 2 billion years, life remained microscopic patient content with its quiet work. It reshaped the planet, atom by atom, filling the seas with green, the air with breath, the sky with blue. You breathe softly, and the universe exhales through you. The first great transformation came when simple cells joined together, one engulfing another, but not consuming it. A truce that became partnership. The engulfed cell became a mitochondrion, a living engine inside a larger cell. From this union, complex life was born. You can rest now. Even cooperation is a kind of light. By 600 million years ago, multicellular creatures swam the oceans, soft-bodied beings called Ediacarans, their shapes like feathers, discs, and fronds. They absorbed sunlight through wide surfaces, drifting in tides older than bones. Then came the Cambrian explosion, a sudden bloom of forms, limbs, eyes, shells, teeth. Life began to see, and once it could see, it began to move with purpose. It's okay to drift. Even motion is a kind of dream. Fish grew spines and fins. Amphibians crawled onto land. Reptiles filled the air with wings. Dinosaurs thundered for 160 million years, their reign vast but finite. Then one night, a meteor from the outer solar system crossed the sky at 20 kilometers per second. The impact ended an age and cleared the stage for mammals to rise. Somewhere, light continues to travel, and among those mammals, a branch learned to stand. It learned to shape stone, to control fire, to listen to the wind. When Homo sapiens appeared around 3,000,000 years ago, the universe learned to look at itself. Through our eyes, it saw the stars it had birthed. Through our hands, it began to study its own origins. You breathe softly, and the universe exhales through you. Your bones carry iron, forged in the hearts of dying stars. Your blood carries salt from the ancient seas. The rhythm of your breath matches the rhythm of waves, of the Earth's molten core, of the rotation of galaxies. You are not separate. You are continuity made visible. You can rest now. The story has circled back to itself. Every neuron that fires in your brain uses electrical potential, tiny sparks, guided by the same laws that drive the Sunday. Each thought you have is a pulse of charged matter, a wave moving through the darkness. You are, in truth, a self-aware ripple of the Big Bang. Somewhere light continues to travel. And in sleep, when the body softens and the mind dissolves, you return briefly to that first quiet, the state before time, the silence before form. In dreams, the brain replays its memory of creation, not in words, but in rhythm. Every heartbeat, every breath, a small echo of the universal beginning. You breathe softly, and the universe exhales through you. The DNA that encodes you contains about 3 billion base pairs. If stretched out, it would measure 2 meters long inside each microscopic cell, and yet it folds perfectly, curling into chromosomes with mathematical grace. Within that spiral are 4 letters, A, T, G, C, that write every creature that ever lived. They are not just instructions, they are music, transcribed by time. You can rest now. You are the song the cosmos has learned to sing. It's okay to drift. Perhaps life began not only on Earth. Perhaps the same chemistry has unfolded countless times across the galaxy. Planets around distant suns, bathed in warmth and rain, may be writing their own verses in the same molecular tongue. In the Milky Way, there are more than 100 billion planets, and perhaps 1/5 lies in a habitable zone. Statistically, life is not rare, only solitude is. Somewhere, light continues to travel. When you gaze at the night sky, you are looking backward in time, thousands, millions, sometimes billions of years. The light from the Andromeda Galaxy began its journey 2.5 million years ago, when early humans first shaped stone tools. That light is just arriving now, touching your eyes, completing a story that began before your species. You can rest now. You have become part of the timeline. In the quiet between stars, the universe remembers its own heartbeat. It dreams in atoms, breathes in galaxies, and thinks in you. The end, when it comes, will not be darkness. It will be return. Matter dissolving into light. Light fading into space. Space folding into silence. And from that silence, perhaps another beginning. Light still travels. The universe breathes through you. You are home. You can rest now. If you're still awake, the next wonder waits in the light ahead.